Well, thanks for coming to this technical mock interview. Do you want to give a quick introduction for yourself, Leonora?
Yeah. Hey everyone, good evening. I'm Leonora. I'm currently doing my master's right now and I'm going to graduate in this December. So I'm looking for the software engineer new grad roles. That would be all. Hey guys, thank you.
Awesome. Let's get right into it then. So
Mm-hmm.
this will be another problem where I'll dictate the problem, and if you need me to slow down or you want me to repeat some parts, let me know.
Oh yeah, sure. I forgot to mention. Hey Leo, can we switch to Python, please?
Oh yeah, I forgot to do that. Sure, Python 3, right?
Yeah.
Man, it'd be really funny if someone used Python 2 in an interview. Anyways, um, okay. So today's problem, we're going to be writing a class or an API
Uh-huh.
that has two functions, add and
Mm-hmm.
count.
Okay.
Okay, so this class, let's call it detect squares,
Okay.
and then we'll have two methods, add and count.
Uh-huh.
And add is a function that will add points to our internal reference, whatever representation memory you choose.
Uh-huh.
Okay, so add points. These will be Cartesian points. Okay,
Okay.
and then count will will be given a point. It'll be given a point as well, so we'll take another point as an input, and it will
Uh-huh.
return the number of squares that can be formed with this point.
Okay. Can be for where's the point? Okay. I'm a little bit confused.
Mm-hmm.
For the count, for we have a input point, and we need to get the number of squares can be formed with a point. Um, so so after we use get, we're gonna get a bunch of points. Like after zeros of the get method, we're gonna have a bunch of points, and now in the count method, we have a new point, and we would like to know if the newly added this input point can be formed with maybe three other points from the all the points we have. Is that is that the purpose for the count
That's
function?
that's a pretty good summary, but I want to get into a bit more detail here.
Uh-huh.
So, like you said, so add can be called multiple times before
Uh-huh.
count is called, right? And
Uh-huh.
in this case, let's just take a simple case in their Cartesian points. So let's say we add the points. So let's just say, so I'll write a quick example as an example here, right? So let's say
Mm-hmm.
we add points 0, 0. Okay, we
Uh-huh.
add, let's see, 0, 1, or 1, 0, and let's add 0, 1. Okay?
Mm-hmm.
If I say count 1, 1, I want you to return 1. Because with the points 1, 1, plus all the points that have been added in the past, you can
Mm-hmm.
form one square.
Okay. Um, got it, I think.
Mm-hmm.
I'm kind of wondering, can we add the same points multiple times? Like
Uh,
given the current, we have 3 points right now.
mm-hmm.
Like after the get add, can we like add the 0, 0 point again?
Yep, you could. Yeah, so you can definitely go in here and add
Um,
0, 0 again. Yep, that'd be fine. But
then
now count will
if
not
we,
return 1 anymore. Count will need to return 2.
oh, okay, cool. So it can be called only after we have at least 3 points. Like,
No, not
uh,
necessarily. It can be called at any point.
okay, so like as long as it won't form any valid square, we just return zero, right?
Yeah, returns. Yeah, if it can't form a point, if there's less than 4 points, so then yeah,
Oh,
it would always be
square.
0. Yes, yes.
Yeah. Okay, and so the input will always be maybe a list or couple of two integers or like floats. Just
In this case,
like
we can see they're integers, just integers. Yeah.
okay, it will always be the valid input. Like will not be some maybe strings or characters or
No,
non-object.
yes, it'll always be numbers. Yes, valid integers. Yes.
Well, so the input. Can I assume maybe it was a list or a tuple?
You can assume anything you want. That's fine.
Okay, so the input is a list of two numbers, two integer numbers. And what we're gonna return is also an integer, like a non-negative integer. Is that correct?
They could be negative. Or sorry, output. Yeah, sorry. Output. So add won't have an output.
Oh yeah, for the count.
Count will have
So
an output, and it
this is
will.
a count.
Yes, count will either be 0 or positive, obviously.
Okay, and this is a count. This is for the count method, and for the add method, it will be the same. And should we return anything for the add method?
Sorry, what's that? Return?
Yeah,
You can
the
return.
return
Yeah,
value.
it doesn't matter what you return. It can be nothing. That's fine.
Okay, so for add, output maybe none or okay. I think I have a clear idea of the description right now. So I think so for considering we might add the same point multiple times. So I'm thinking using a dictionary to sort of record to map the point, like the x and y coordinates, to the number of times it has occurred. So like for example, given an example, we have add 002 twice, then we can have a map which map um, 0, 0 to 2. So I think that would be the function. So we're gonna maintain a sort of a dictionary in our class, and that's what add method would do. Just keep updating this dictionary. And for the count method, so I think given we need to form a square, and so like all the four sides should have the same length. So I think if we have so given a point, the other 3 points, so two of the remaining 3 points should have the same x coordinates and the y coordinates. So like one have
That's
the
right.
same x coordinate and the one have the same y coordinate. So we could be able to, and for the given point,
I'm gonna before we move on, I'm gonna just quickly clarify something, which is that in this case, when you said they have the same x coordinate and y coordinate, you made the assumption that the square is not rotated.
Oh yeah.
For this case, let's start with that assumption. So that's
Okay.
okay to start for now. Yeah.
Yeah, that's the case. So I think so for a point, we can in the add method we can also maintain another dictionary to maintain all of the points that have the same x coordinates. So in this case, in the count method, when we have a new input point and we know it's x coordinate, we're gonna find all the other points that have the same x coordinate. So we like all these x coordinates are the potential candidate for one of the remaining 3 points, and we can check one by one for them. So let's see. Okay, so given us still this example, we have maintained so if the x coordinate is 0, we have 0, 0, 0, 1. And now we're gonna count and for 1 we have 1, 0, and now we have count 1, 1. So we're gonna first find the points with the same index coordinates, which is only the 1, 0. So that's the only candidate. And for if the point is 1, 0, it means that the side would be 1. And then in this case, we have fixed 2 points. So the next point we have fixed is a point that have the same y coordinate of 0, 0. It could be the one like above it or the one under it. So the first candidate we have fixed is 1, 0. So given 1, 1. Given 1, 1. And the second candidate can be 0. Oh, so can be 1, 0. So this is the candidate under it, and or 1, 2. So we can check if 1, 0 is in the point that we have, which is oh no, it's like 0, 1 and 2, 1. Okay, so we're gonna first check if we have 1, 0 already, and it's a case. And then so now we have fixed all the 3 candidates, and the only remaining point must be fixed right now. It can only be okay. It can only be the point 0, 0. So now we need to check if 0, 0 will have 0, 0 already, and then we do have it. So now we need to see how if we had 0, 1 or 0, 0 multiple times. So it seems that we have add 0, 0 twice, and 0, 1 only once, and 1, 0 is also only once. So the number of squares that can be formed with 0, 0, 0, 1, 1, 0, and 1, 1 would be 1 times 1 times 1 times 2, which equals 2. And now we check 2, 1. Unfortunately, we do not have 2, 1 in the points, so this case won't work. So we're gonna return for the this 1, 1 for the count method would be 2. I think that's the idea for the count method if the square is not rotated.
I agree. And in this case, to confirm, right? So your math here is calculating. This is already calculating all of the possible squares with the given number, correct? Okay.
Yeah, we can ignore the first one. So the first one here basically denotes. So each of these 4 numbers represent the number of points we have. So since we are given 1, 1, so we can ignore the first one.
Yep.
And now we check the first candidate. The 1, 0 only appears once. So if 1, 0 appears twice, then the first one will change from 1 to 2. And the second one represents the number of times 0, 1 appears, and 0, 1 only appears once. And lastly, 0, 0 it appears twice, so we multiply it 2.
Yeah, that all sounds good to me.
Cool. So can we jump to the code?
Let's go for it.
If the algorithm. Okay. Cool. So we have maybe have a class maybe named square, and we're going to have the constructor, and we're going to have the add method. And method is given the input is on the point, and we put a placeholder here, and we're going to have the count method, and also the placeholder. So since we're going to document the number of points, the number of times each point has occurred, and also the points that share the same x coordinate. So I'm going to use dictionary to record this. So here maybe self dot point to count, and self dot x 2 points.
Mm-hmm.
So to dictionary,
Yep.
and then so
Just a quick
for
for my sake. Can you tell me
mm-hmm.
the types of these, the key value for both?
Oh yeah, so
Just common is fine.
for
I don't need it. I don't need that type. But just common is okay if that's more convenient.
yeah, so the point would be from the integer to integer map to integer and tuple. The key is tuple.
Mm-hmm.
And for the x 2 points is integer map to also a list or tuple. Like int map will be mapped to tuple consists of two integers.
But just to be clear on this one, on the second map, your key
Uh-huh.
and its value, the value's first index will always equal the key, correct? Is that what we're
Oh
implying here?
yeah. Yeah, in this case we can just maybe record the y value then.
Mm-hmm.
So
Yeah,
it could
that sounds
be
better to me.
x uh, map to the y coordinate.
Mm-hmm. Yep, that's better.
Okay, then so for the AND method, so we first need to get the x, y value from the point, and then we need to update our two dictionaries. So like self dot point to count the set default going to map the x and y. Oh, okay, we don't need this. X, Y. So if does not exist yet, we're going to set a default 0 value for it. Else we just increment its original value by 1. And then we're going to add the the dictionary for the points of the same x coordinates. Self dot x 2 points x. Okay, so I think in this case, instead of mapping it to only one integer value, we can map it to a list of integer value. So list of 180 integer, and so now we need to use the set default here. The x, if x has not, if we do not have any point that have x as the x coordinate value, then we're going to create an empty list for it. Else we just append the y value to it. So I think that's the idea for the add method.
Mm-hmm.
Does it look good to you?
Yeah. So one thing I want to check on this one is I like the
Uh-huh.
idea of having the x coordinates mapped to a list of y. That's cool. Um,
Mm-hmm.
that I guess depends on how you're planning to use the list of y, right?
Yeah.
Because in this case, you are indiscriminately adding y to the end,
Uh-huh.
and so there will be no order in this list.
I was thinking if we should use a list or a set because I think the order does not matter, or we want just all the points with the same x coordinates. So when we check given when in the count method we have the point and we get its x coordinate, I think we do not care the order of the points that have the same x value. We just want to know its y values.
Mm-hmm.
So that's the case. And I was thinking if we should use set instead of list so we can avoid adding multiple. If we're going to add the same point multiple times, then we do not need to add the same y to itself the x 2 points multiple times. Like we can only add one y to it, and then we can use the self dot point to count to retrieve the number of times this point appears in this class.
Okay.
How does this
That's
sound?
that sounds fine to me. We can proceed on this for now. That's not a big deal. We can continue.
Okay, cool. So then for the count method, so we first need to get the xy value from the point. We need to have the candidate to check each first candidate one by one. So we can name it just to make it simpler. We can use x1, y1, x2, y2, x3, y3 to name all our 3 candidates. So for y1 in self dot x2 points in x. Okay. So before we going to check this, we need to make sure we like x exists in the self dot x2 points. Like so, if we do not have any point that have the same x coordinate, we can just return 0. So if x not in self dot x2 point, we can just return 0. So now we're going to check the first candidate. So we're going to check each y coordinates one by one. And if, so like for each y1, we have fixed 2 points, and we're going to get, this means that we know the length of the square. So the length would be the absolute value of y minus y1. And now we can try to figure out the next 2 points. So for the second candidate, we only have 2 options. So the second candidate could either be to the left or to the right of the given point. So we can check one by one. So to the left, and then to the right. So if the second candidate is on the left, then it means that the x2 equals to x minus length. So in this case, we so let me use a sort of droid here. So we have the original xy, and we have figured out the first candidate, which is x1, y1. It has the same x coordinate, so it might be on top of it or beneath it. And so we have these 2 points, and now we have the length, and we can figure out the second candidate. It could be here, x2, y2, or it could be here, x2, y2. And we are checking the one on the left. So now we have the x2, which is x minus length, and y2 would be the one with y2 would be the same as y. So y2 would be this one, and now we have figured out the x3 and y3. X3 would be the same one as x1. So here x3 has to be here. So in this case, x3 would be the same as x. Okay, let me think of it. The same as x2. And y3 would be the same as y1. So now we need to calculate the count. We just basically need to know the number of times x2, x1, y1, x2, y2, xy, x3, y3 appears in our points. So it's like self dot point to count dot get x1, x1 would be just x. So we can like make it here, x1 equals to x, x1, y1, x2, 0, and times self dot point to count dot get x2, y2, and the same for x3, y3. So now we finish checking to the one on the to the left, and we're going to basically repeat the same for the if the first candidate is on the right. So now x2 instead of x minus length is x plus length. So it's this case. And then x3, y3 will be here. So it's like x2 will be x plus length, and y2 will be the same as y. And x3 will still be the same as x2, and y3 will be the same as y1. And it's still the same. And what we're going to return is, let's name it count 1, count 2. What we're going to return is count 1 plus count 2. So I think that's the idea for count. How they say it?
Are we returning inside the for loop?
Oh no, I missed it. It's not within the for loop.
Just making sure.
Yeah, I did not see it in my screen. Sorry about that.
I think you need to save your two variables somewhere.
Oh yeah. So we can, before we enter the for loop, we can have a count variable. And so instead of use count 1, we can just add it to our count variable. And then we're going to return count. So that's it, I think.
Great. Let's go through the time complexity and space complexity for your class here.
Yeah, sure. So for the add method, it would be if it be all of one, like if we do not consider the time complexity for the hashing. So we basically update the value here, and then so the time complexity for add would be all of 1, and for count, the time complexity would be we need to check each y1, and then within each for loop, within each iteration, the time complexity is just all of 1. So I think if let's say we have in total n points in our square up class, and the worst case is all of the points have the same x value. So then self dot x2 points s would be in the worst case would be length n. So in this case, the time complexity for this for loop would be O of n. So I think that's the worst case.
Sorry, I missed if you defined n. Can you define n?
Yeah, so n here means the number of points in square class.
Okay.
And so here the time complexity for count would be O of n. I think that's the two complexities for the add and count method.
Okay, that's the time complexities. And can we talk a bit about the space complexity here as well?
Oh yeah, sure. So for the space complexity, we're going to maintain two dictionaries here, the self-dot-point count and self-dot-x2 points. In the self-dot-point count, in the worst case, all the points we have are unique. Then in this case, the self-dot point count, if we still have assume that we have n points in the square class, then the self-dot point count will consume all of the space complexity. And if we have if all the points have different x coordinates, then self-dot x 2 points would consume all of n space complexity as well. So I think the space complexity would be all of n.
I might have missed that. You mentioned how if they have different x coordinates. Does that space
Yeah,
completely? Can you elaborate on what that means?
yeah. So like if yeah, I think it might not. I think so. That's okay. So instead of just counting the number of the unique x coordinates we have, we need to, because we're going to map each x to a list of y coordinates. So I think what we're going to count is actually the values here. So I think we can like ignore the number of unique y. The space complexity for the self-extra point will still be all of n, because we're going to have, if we have n points, then we're going to have n y coordinates.
Yeah,
Yeah.
that sounds more right to me. Um,
Yeah. Okay.
what if now to kind of build on that, right? Like, what if I tell you now that the problem space of the input, or rather, there's a restriction, or how
Mm-hmm.
people use your class is that they tend to add the same point multiple times, right?
Mm-hmm.
In that case, uh, what sort of optimization can you make with the given code?
So I think we still need to know that like self-dot point count would behave the same, and like for self-dot extra points, we can update from using list to using a set.
Mm-hmm. Is there a reason to not use a set here, or is it only positive?
Um, I like I'm a little confused about, is it only positive?
So that sounds like a approach. We can talk about that first. So we can change it to from a list to a set.
Uh-huh.
Can you make that change?
Yeah, so we can make it to a set
Mm-hmm.
and then add it here. And I think the code for count would still be the same, I think.
Okay. So if it's the same, is there any reason to not use a set here, or was it only a positive thing that we're using set now?
Oh, okay. So it's like if we're using set, we can reduce the number of iterations in this for loop. So we might end up like recalculating the same y1 multiple times. So we can just, let's say if we have three y1s which all have 1 as the value, then if we're going to use list, we're going to like going through the same four iterations 3 times. But if
Mm-hmm.
we're using set, we're going to like enter this iteration only once.
Yeah. Yeah. Exactly. So in this case, it's only beneficial to use a set.
Yeah.
There's no benefit to using a list in that case. Now, um, there can be a benefit to using a list. So let me instead put it this way. Um,
Mm-hmm.
so now this is so now people might not put the same point multiple times. Now this is a different kind of situation. What if now
Mm-hmm.
people when they add points into uh, to your class, they prefer to add points that are closer to the origin. Right now the
Um,
canvas. Remember, the canvas is still infinitely large. Okay,
mm-hmm.
but the density of points is higher in the origin. In this case, are there
Okay.
any sort of optimizations that you might consider making?
Like, can you like describe how close are the points to origin?
Well, it's just a relative density. So, for
Oh,
example, let's
okay.
say that within the square x and y equals plus minus 10, that
Uh,
contains 50% of all points. And then from x and y equals plus minus 20, that
mm,
contains 75% of all the points, and so on and so
okay.
forth. So there's a relative density. Now, the exact number there doesn't actually matter. But let's say now, in this case, right, the points are people add points that are closer to the center. In this case, what would you consider changing? So from the given code right now, right, you have your point to count and you have your x2 points with a set of y int. What would you consider? Is there anything? I'm not saying you have to. Is there anything you would consider changing to improve the average complexity of your method, of either add or count? I mean, add is O1 already, but so any thoughts there about this?
So I was thinking like, so if 99% of the points are within the range of like x minus x plus or minus 10, like y plus or minus 10 of the origin, I was thinking instead of using like the dictionaries, like just maintain the a fixed size array.
A fixed size array, okay. And
Yeah.
can you go into a little bit more detail here?
So because we if like 99% of the points are within like the square, maybe 10, the x plus or minus. So let me document here. So if we have the points for the x value are in the range of 0 plus or minus 10, and the y value is 0 plus or minus 10. Instead of using this the self.point to count and self.x to points, we can just maintain like a fixed size array of 100. So like self dot maybe location to count, and it would be so the size array of it would be array of 100, I think. So each of the element would represent a cell in the canvas. So let's say we can just use maybe we need to map the each location to index. So so let's assume we have a location to index map here, and then the self dot count would be index, and the value is the count here. And I think to map the location to index, we can use something like maybe the x value time. Yeah, we need to come up with a mapping logic here. I haven't come up with one yet.
Okay.
If it looks good to you, like we can go deeper into it.
We don't need to go too deep into this, but I want to just ask, what's the intuition here for using an array? Is that actually more beneficial than a map?
I think that is we're going to have a fixed size which is all of 100. So the space complexity would be all of 1 instead of all of n. And for the count method, instead of looping through the self dot, it would basically we still need to check the points in the with the same x coordinate, but instead of having the for loop would not have any iterations. We have I think the most beneficial would be for the space complexity.
Okay, that's good. That makes sense. But you would still, but for the 1% of points that are outside of plus minus 10, how are you gonna handle those?
Yeah, we can use these two additional dictionaries for that.
I see. And so these dictionaries, will they still contain points within plus minus 10?
No. So for the points within the range, like minus 10 to 10, we're gonna store it in the fixed size array, and for points outside this range, we're going to use the two extra dictionaries for that. but it's like because it's only for the 1% of the points, so I think not like only a few points will go to these two dictionaries.
That's okay. Yeah. Well, I mean, 1% in this case, right? So 1% of the points. Yeah.
Yes.
Okay, that makes sense. Um, there's a still so that sounds pretty good to me. Now, if we go back to the original question, so without the density, so now we can talk about uniform density roughly, but
Mm-hmm.
um, in this case, there is a pretty so in this case you are arbitrarily choosing your count. You're arbitrarily choosing, or and your data structure. You're arbitrarily choosing to fix x. You're mapping x to a list of y's,
Oh,
and not y to a list of x's,
yeah.
right?
Yeah.
Now those are obviously logically the same. Was there a reason you picked a map of x to a list of y?
Um, yeah, actually, you remind me if here, if y1 is the same as y, we can skip this iteration. Um, okay, so I think it's because, so the idea is we have the first point, we're given a point, we want to find all the remaining candidates. And what we know about the candidates is one of them have the same x coordinate and one of them has the same y coordinate. So it's I want to map x to a list of y values. Is I want to simplify how we're gonna determine our first candidate.
Mm-hmm. Right. And in this case, that is correct. That would work. But uh, and this would work the same as as a mapping a y to a list of x if the points are
Yeah.
uniformly distributed. So they'll be identical. I agree with that. Um, in the situation where that guarantee is not made, right? So for example, you might be storing data that is very, very, very heavily linear. And what I mean by linear in this context is that,
Oh.
for example, let's say you map x to a list of y's, right? Let's say that this person might have a lot of vertical tall rectangles or a lot of vertical points, a lot of tall vertical points, right?
Uh-huh.
Then this particular assumption you made would suffer, right? So in this case, what I'm saying is that if this person had a lot of y's per x, in other
Mm-hmm.
words, they have vertical lines, right? They had a lot of vertical kind of lines, and they're adding in.
Mm-hmm.
There would be a penalty in your case, right? There would be a penalty that's disproportionate. Is there any sort of insurance, or maybe an additional structure you can use to help mitigate any non-uniform point assumptions,
Any other data structures?
or any additional structure? You might not need to change what's going on, but
Um,
do you see the example I'm giving? Right. In this case, if you had, for example, this person added x 0, 0, 0, 0, 1, 0, 2, 0, 3, all the way to 0, let's call it 0k, right?
mm-hmm.
And they added 1, 0, 1, 1, 1, 2, 1, 3, 1, all the way up to k. And
Mm-hmm.
they might add then 10,000, 0, 10,001, 10,002, all the way to 10,000, comma
Okay.
k. If this had a
Mm-hmm.
very vertical structure, if it was non-linear in this context, or non-uniform, was very linear in this context,
Okay.
what kind of
I
insurance can
got
you
it.
apply to avoid this kind of situation,
So
or
I
to
think
avoid
in
taking a
this
penalty?
case,
Yeah.
yeah, so I think in this case, in addition to maintaining a map from X to a list of Y coordinates, we can maintain another dictionary mapping Y to a list of X values. And then for in the count method, given a point, we can check like the number of first candidate, like the count of the first candidates if we fix X value, or and the count of first candidates with the same y value. And we're going to start with the one has that with a smaller value.
That's exactly right. Okay,
Okay.
that's what I was looking for. Great. That is the most of the follow-ups I had for this one. I wanted
Mm-hmm.
to end it here for this mock interview. I
Okay.
mean, let's get your thoughts first. I think you did quite well. How do you feel so far?
Yeah, I think I sort of made a mistake. At first I assumed the square is not rotated, like it's parallel to
Mm-hmm.
the x and y. So I had to admit when you pointed out, I was much nervous. Um,
Yeah.
and I think I think when I was explaining my idea to you, my idea was not it's like just a rough idea. So then it means that when I jump to the code, I haven't have a much clearer idea about the code structure.
Yeah.
Like maintain the variables too. I know I need to maintain the map from the point to count. I sort of need to know maintain a dictionary to know the points with the same x coordinate, but I haven't come up with like the clear idea. So as instead of using mapping x values to y values, I map the x values to the points directly. And a little bit sort of mistakes like in the count method.
Yeah.
So
Yeah.
about the edge, so like if the y1 is same as y, I continue that. And actually, also like if I'm going to use a list of y8 and in the count method, if I follow this one, I think I might end up adding the same the same group of 4 points multiple times. So I have to use that for my code, for my current account code. If I'm going to use list, I shouldn't, when I calculating the count, the increment value for count, I should only use the the number of times the x2 and x2, y2, x3, and y3 occurs instead of like all the way counting x1, x2, and x3. So
Yeah.
I
Yeah.
think
Exactly.
that's a point.
Yeah. So a lot of the errors there were mostly they were not logistical errors. They were just edge case errors. So that's not important to point out. But that's good that you caught them at the end. One of the things that that I was prompting about why you would use a list in this context,
Uh-huh.
right? So you start with a list of points, which is fine. But again, like one of the issues is that, right, every time you encounter a given point, like what you just said, every time you encounter a point, you're already multiplying all of the points count together. So you would
Mm-hmm.
double count for 2 points, right? Um, the most common way I see people get around that actually is instead of storing a set of points, they actually just have a visited set inside a count. So
Oh
I was
yeah.
expecting that response, but when you said to change the entirely in a set, that would be actually a bit more efficient, right? Now
Yeah.
one of the issues with changing the one of the issues with changing the not an issue, but like one of the consequences of changing it to a set. There's two things. First of all, there's an implicit assumption that you make that every point is uniformly distributed. Now, this is not something you asked
Yeah.
at the beginning, right? You did
Mm-hmm.
not ask about the distribution of points.
Yeah.
Um, this is a bit more of an advanced problem. So, unlike the previous question about implementing math.power, um, this input is much more abstract, right? But the same questions still apply, right? So, for example, this applies to all sorts of problems, right? If you're given a problem with the state management,
Mm-hmm.
you're generally most problems with Leetcode and most problems you'll be asked at this level with
Mm-hmm.
state management, there'll be basically one read and one write. That's sort of like the style, one read and one write. Okay,
Mm-hmm.
and so in this case, right, the write is add and the read is count. Okay, now
Okay.
the key thing there is that the data you store has to be informed by the data you take in, right?
Mm-hmm.
And so, for example, you were correct in actually pointing out that if the density was very high near the origin, you can avoid you can use a list to avoid some penalties. Now, here's the thing: is that the analysis there wasn't actually exactly correct. Um, you are right in that, yeah, sure, that's actually a good approach to use a list instead of a hash map, but the complexity
Uh-huh.
is actually still the same. Like,
Yeah.
this complexity is still the same there, so that doesn't actually help. The reason that you would preferentially use a a um, a list instead of a hash map is that you don't need to hash the numbers, right? you
Uh-huh.
don't you
Oh
don't need to
yeah.
run the hash function, right?
Mm-hmm.
The hash function, the time complexity of the hash function scales with the length of the numbers, and it scales with,
Yeah.
and it depends on your key. So it does depend a bit there. Now, one other detail. Now that it's a small detail, so I'm not. No one's gonna mark you really wrong for that one because you still have a good intuition for that one, right? But and another thing that's this is much more detailed, and this will be very impressive. If you bring this up in an interview, is the notion
Oh
that in a
yeah.
hash structure, hash structures
Mm-hmm.
they're stored in buckets, And so
Yeah.
x equals 1 and x equals 2 are not stored next to each other because the hashing
Yeah.
splits them randomly, uniformly apart, right? Now,
Mm-hmm.
because I made the assumption, I've given the assumption and given you the information that the density is high near the origin, you
Mm-hmm.
actually want x equals 1 and x equals 2 to be near each other in memory, because that, even though the
Mm-hmm.
time complexity is the same, it has better performance in real life since it has
Yeah.
better cache coherence, as it
Mm-hmm.
has, so there are actually reasons for that kind of stuff. So if you're able to bring up some of
Mm.
the more systems knowledge that you acquired in
Oh,
school,
okay.
that would really kind of elevate that explanation. So that's something I have to
Got
point
it.
out there, and I feel like you could actually leverage that because that is a bit more advanced point, and I saw that you actually had intuition for that. So I think you could actually leverage that a bit. So what does that mean? If you know these things, if you know about some of the memory kind of levels of
Mm-hmm.
computer science, that would be really, really good to kind of revisit, right? Like, for example, whenever you're thinking about, oh, should I use a list or a set? One of the advanced consequences is lists are backed linearly in memory, usually, not
Mm-hmm.
always, but almost always, right? And I mean array lists, not not linked lists. Linked lists are
Yeah.
different, right? And hash structures do not store items linearly in memory. And so if you
Mm-hmm.
benefit from having fast linear access, then that is a good reason to use arrays. And that is also why in real life, a lot of the sorting algorithms for small lists, like less than 30, if you look at Java's source code or Python as well, the
Mm-hmm.
sorting algorithm is called timsort. Timsort is actually just merge sort for large lists, but the base case for list of size 32 or less is using insertion sort. Now you'll note that insertion sort is in squared, not in log n, but
Mm-hmm.
it's still used because insertion sort scans arrays linearly, and so it ends up being much, much, much faster than any recursive or random pointer sort. So there are some real life consequences of this, and if we're able to bring that out, that would be like super impressive. So I mentioned this one in this interview because I feel like you could really take advantage of that. Um,
Got it.
Otherwise, let me just quickly. I took a lot of notes. Let me just quickly scan my notes real quick. Give me a second. Uh, Good math. Yeah, good math. Good questions at the beginning. Yeah, the square alignment I think is a bit, you know, that's a tough one. Um,
Yeah.
People who have seen the question on Leetcode will automatically assume that, and then you can say, "Oh, I wonder why." But also because the question, um, there is a follow up question some people ask, not very few, ask where you cannot assume there's axis alignment, but that question becomes a lot more of a math problem than a
Mm.
good problem. So most people won't ask that. But it's actually, but like still, you should clarify that and confirm that's the case,
Yeah.
right? Because otherwise, that's a mistake, right? That counts as a misunderstanding. So
Yeah.
yeah, otherwise, yeah, I don't think I had anything too much to say. The implementation was very quick to come out. Good intuition to start. Um, there's some right there's a little bug there with the double counting and the length equals zero. That's what I wrote, length equals zero. But I think the follow ups were actually quite well answered, and overall, this was a pretty strong performance.
Okay.
Any questions on your side, or otherwise we'll call it here.
No, thank you so much, Leo. I haven't like when I was like work solving the legal problem, I didn't actually think of like maybe leveraging some lower level knowledge. So
Yeah, well,
I actually learned a lot from you. Thank you so much.
for sure. Oh, well, to be clear, right? Like when you're writing implementations, you shouldn't be trying to optimize that kind of stuff. But
Mm-hmm.
follow up questions are the perfect place to discuss theoretical things, right? It's
Mm.
time for you to demonstrate knowledge without really having to implement things. So that's when you can talk a lot about the knowledge you have. So definitely in the interview when you're writing stuff, definitely it's just like write stuff the basic way, the correct way. As long as the time
Mm-hmm.
complexity is the same, it's fine, right? But when you're doing
Mm-hmm.
the follow ups, that's when you can kind of show off a little bit.
Okay.
Awesome, great work.
Thank you so much, Leo.
Take care.